last thing of this unit is called the average value of a function. Okay, for instance, if you got a 70, you got 100, and you got, let's say, 75 as far as test grades, what's the average? You would add them all up and divide by what? 3. You would divide by 3 because there's a space, basically, of 3 accounting numbers so that you get your average, right? Now, that's what's going on with what I'm about to show you here with the average value of a function. If I were to graph this function right now, it is a quadratic that's shifted 3 units to the what? To the right. 1, 2, 3. And it looks like this. And we're looking at from 2 to 5. So 1, 2, 3, 4, 5. So if I asked you the area underneath the curve, it's this and that on this interval. Would you agree?
Yes.
Okay. Now, the average value is going to have this interpretation of how many pieces are there that we need to divide by. So here we go. 1 over b minus a times the integral from a to b of whatever function we want to integrate. This is the equation of the average value of a function. Now, here's where it gets slightly confusing if you're not paying attention. If I want to find the average value of y, or f of x goes in there, not f prime of x. Okay? Not f prime of x. The average value of f goes in there. If I wanted you to tell me what's the average acceleration, what derivative will go in there? The second derivative. Okay? Because this is what it's doing. Let me show you what it's doing. From 2 to 5, this area underneath the curve, remember the way I showed you with Riemann sums rectangles? Let's solve this out by hand. So x minus 3 squared dx 1 over b minus a. So it's a jump of 3 from 2 to 5. You with me? Okay, so now let's integrate x minus 3. We can do u sub. We could say u is x minus 3, du is dx. So the substitution is going to be u squared du, and it's going to be this 1/3 that was the original constant multiple rule. Okay, just u substitution. So this becomes u cubed over 3 times that 1/3, right? And it's going to be from a to b. In this case, it's going to be from 2 to 5. So this is 2 to 5, and this is 2 to 5. You with me? Okay. So now I need to plug what back in for u? X minus 3. So I have the integral. Let me go ahead and do it over here so you have more room. I have x minus 3 cubed over 9 from 2 to 5. So that's 5 minus 3 is 2. Cubed is 8. That's 8 ninths. 2 minus 3 is negative 1. Cubed is still a negative 1. So it's going to be subtracting a negative, which is adding that. So my average value of the function is 1. That means, guys, when I come over here and I see what these are, I could say this is 1 right here. That means this average value is like if it was just a straight up line right there at 1. Okay? When I listed out those numbers at the very beginning, 70, the 85, and then the 100, or whatever I listed out, if I asked you to tell me what the average is, you add them all up and divide, right? Well, the average is, we just did that. This average of 1 is the average of all of these points. In other words, if it was was at 5, what would that y value be right here? Well, 5 minus 3 is 2. 2 squared is 4. You with me? So that would be 4, 3.9, 3.8, all these infinite y values, and then these that go down. But if I add them all up and divide by the width, or how many there are, I could know exactly what was my average. You with me? Now, what's cool about this is that this average creates this perfect rectangle where all this overage right here would fit perfectly in here, which you would have this perfect average of the high minus low, the b minus a part, times the height, or that y value of 1. This area of this would equal the area of the original equation. It all represents the average value of a function. Okay? So, recap. If I asked you what the average jerk was, you'd put f triple prime there. If I asked you what's the average velocity, you would put f prime there. And then just work it out as normal by hand. Okay? Now, find the value of c such that this is equal to the average. What did we say the average was? 1. So 1 is equal to the value of c. So it's going to be c minus 3. And you can leave x. It's just saying c is an arbitrary x. So you can leave x if you want, and all you're going to do is just solve for it. You with me? So you square both sides, you get 1 is equal to c minus 3. You add that, and c is equal to 4. So find the value of c such that the average would equal to that, and c would equal 4. Okay, so that means right here, guys, look, at 4, that's where you would equal this 1 that I'm talking about. That's the only place where it equals it. It wants to equal it over here, but this is not in the domain from 2 to 5. Any questions? So the c is, where does it exist? It almost feels like intermediate value theorem a little bit. Okay? Any questions?